All right, we're going to look at some applications of exponential and logarithmic functions. Um, and one thing that we'd like to look at is doubling, tripling time, and halving time. So again, as I'm written here, sometimes we like to have these milestones uh, that kind of mark a certain passing. And for exponential and other applications, sometimes the doubling time, tripling time, or halving time has special meaning. So let's look at how we figure these questions out. Let's say you invest $1,000 in an account that earns 40% yearly interest. So again, what does that mean? Does that mean that T is in years? So that's the unit. Compounded monthly. So what does that mean? Well, if it's yearly interest in it, it's compounded monthly. There's 12 months in a year, so n is a 12. The question is, how long will it take the amount to triple? All right, so let's first start with writing our equation that's, start putting the pieces in place. So what I'm investing is 1,000. Um, I have a 4% interest rate, yearly interest rate, compounded monthly, so it's 12. And there it is. There's my equation for compound interest. So now what I'm going to do, this says how long will it take the amount to triple. So here's the amount I originally invested. Now I want this amount to be 3 times that much. So I'm going to write that exactly that, 3 times 1,000. Get the following. Okay. Now I'm ready to solve for t. I see that t is in the exponent, so notice this is going to be an exponential function. Why? Because the exponent, I'll show you the exponential equation, because the variables of the exponent. So now I'm going to start solving. So if I need to bring this down, I need to clean this up. I need to just be the exponent exposed, just exponent, not other things hanging around, like adding something or multiplying by something. So I'm going to divide both sides by 1,000. Now I wrote this purposely so you can see that when I divide both sides here by 1,000, all I get is 3 equals 0.04 divided that by 12, 12t. Great. And notice what this tells you. This tells you that the original amount doesn't really factor into how long. The question is, how long will it take the amount to triple? And this says it doesn't matter. How much you invest does not matter. So investment amount does not factor into how long it will take the amount to triple. So keep that in mind for other questions. That's always going to be the case. If we want something to triple, the original start doesn't really matter. What does matter, though, is the rate. Okay, so that does matter. The rate is what governs how long it will take to triple. So now I'm going to continue solving this. I need to get this exponent down because that's where the variable is located. So I need to take the natural. So I need to find the inverse of exponentials, which is taking logs. Since I want to find a approximation to this answer, I'm going to either use log base 10 or natural log. Natural log being my favorite, I'm going to take the natural log. You could also just take the common log, log base 10. So there I took the log of both sides. And when I do this, I could use the power rule to bring that exponent down. Like so. And what kind of equation do I have now? Look closely now. This is now a linear equation. So keep in mind that every step that we do to solve an equation, it's striving to get back to a linear equation. And why is it, I say this is linear? Because this is just a constant. It's a number. That's just a number. So I have a number times t. That's just a constant over here. So all I need to divide is divide by 12, divide by natural log of all this stuff, and I get my result. So natural log of 3, divide both sides by this, and I have my result. And that's the exact answer. But of course, that doesn't help me at all. So I'm going to take a calculator and just approximate. There's something, my calculator, clear here, and I'm going to take my natural log button, natural log of 3, close it, divide by. Now, because with what's sitting in the denominator is a lot of stuff, I'm put parentheses around it. So divide by 12 times natural log of, and then everything is inside here, 1 plus 0.04 divided by 12, close it, check if it looks good. Yep, looks great. Return, and looks like a 27.51, and notice the unit is years. So how long will it take to double? Approximately 27.51 years. Let's look at another question. The radioactive substance RB20, which of course is just all made up, there's no such thing as RB20, has a decay rate of 1.1% a month. Great. We use it continuous compounding and start with 80 grams. How long will it take to half that amount? So again, I'm going to write first the equation, putting everything I know. It's 80. I'm going to use continuous compounding. E, and the decay rate is 1 per month. So notice because 1 per month, T is in months. So I always have to figure out what this is, and then that's what T is going to be in. So it's a decay rate. So I need to make negative and change this to a decimal. Again, move the decimal 1.1%. Just move it over twice, or take 1.1 divided by 100 to get what it is. And that's times T. There we go. And now the question becomes the half-life. So the half-life is how long will it take to half the amount. And you notice, we're talking about radioactive material. We're always talking about how long will it take to be half what it used to be. So I'm going to write the same thing. I want it to be how long will it take to half the amount. And this becomes the half-life. So half of 80, that's what I'm looking for. Yep. And again, I need to solve here and have an exponential, again, because it's an exponent. So I need to divide both sides by 80. And you'll notice I did that again purposely, divide by 80, and you can see that immediately what I have is just this. And just like before, we see that the original amount does not really matter. This tells us that it's irrelevant. It goes away. It's not relevant. What I want here is just, here's my exponential. I need to be half, like half of 1. It doesn't really matter. So I'll take the natural log of both sides. And this one's nice because my base is E. So now these are inverses of each other. So what I have is just the input right here. And again, what kind of equation do I have? It is now a linear equation. So I come back, divide both sides by negative 0.011. And that's the exact answer. If I want to have an approximation, I will just enter it into my calculator, and away it goes. I'm going to go natural log of 0.5, close it, And divide that by negative 0.011. Sure that's right. It is right. Boom. And it looks like it's going to be 63.01 about, I mean, approximately. And what's the unit? Month. So it's months. That is how long it will take for the amount to half to its previous amount.